We found something we weren't supposed to find, okay? And we had a peer review. We had a peer review of us, the structural engineers. We had a peer review of the geotechnical engineer. We had a peer review of the wind tunnel. And so as part of this peer review, we had another wind tunnel review, RWDI. We had essentially Western Ontario. And one of the things that we were discovering is that the faster we blew the wind in the wind tunnel, the lower the forces were. And that kind of made us nervous. Why is that? Okay, when you take a building and you scale it down, okay, you can it's called similitude. Okay, this is done a lot in science. You can scale the structural properties. You can certainly scale the geometry, and you can scale everything, but you cannot scale the fluid. Air is still air. Okay, and it turns out that it doesn't matter as long as you're in turbulent flow, and you tend to be safe. And so, because of that, this conventional wisdom was that this should not have been happening. We should not have been getting reduced forces. So you can see for various wind speeds in the wind tunnel, we're getting dropping. So here's like a high frequency force balance wind test, and here was a Merrill elastic, and here's an elastic when we really cranked it up, and then they went faster and faster and kind of stabilized. But in fluid mechanics, there's something that you see when you have like fluid drag over a cylinder. When you have like a laminar flow, you'll get a certain amount of drag, and then it'll drop down, and then at a very much higher wind velocity, you'll actually get worse than it was at the lower speeds. And so we thought it behooved us to find out if we had a problem or not. And so we decided to do a test. This is a test of only a part of the building. And it's a relatively big model, okay? just to give you an idea, okay? And this was solely to test the Reynolds number, to be sure that we didn't have a problem, that it wouldn't come back up. And this was a pretty expensive test, okay, that we did. But we actually did establish that we weren't going to have a problem from the Reynolds number. And Reynolds number is a measure of turbulence and viscosity, if you will.